Hi everyone, and welcome to our final tutorial. This is tutorial 10, and today we're looking at non-parametric analyses. So up until this point in the course, everything we've done can be labeled a type of parametric analysis, or an analysis that uses the mean with the standard deviation. But there are many circumstances where it doesn't make sense to use the mean. For example, let's say I have a distribution, and it looks a little bit like this. So we've got a positive skew, right? If I was to look at my mean, median, and mode, so first look at central tendency, I'd find that my mode is somewhere about here, and then my median would be a little bit higher up, and my mean is probably dragged really far out to the right-hand side. So when I've got skew and other issues with normality, I'm going to see that my mean starts to behave very strangely. Whereas my median, not so much, and my mode's not affected at all. Now, you can't really analyze a mode, there's not much you can do with it, but medians are often quite a nice alternative to the mean. So, non-parametric analyses are a set of analyses that mirror parametric, so we have non-parametric equivalents of t-test, of ANOVA, of regression, of correlation. But rather than using the mean, these analyses have been changed to use the median. So to give you an idea of what's going on here, let's say we had a study. Let's use something absolutely ridiculous. Let's say we gave some participants marijuana and some participants cocaine, and then we made them run on a treadmill. And we measured how long they could last running on a treadmill. Now what we might find is people who had, say, weed, we might see that they had measures of, I don't know, 1 minute, 3 minutes, maybe 4 minutes, maybe someone had 7, and maybe someone else had, I don't know, 11 minutes. And then the people on cocaine, maybe, I don't know, I'm just making stuff up here, but maybe someone had, say, 5 minutes that they lasted. Someone maybe lasted 8, and then 9 minutes, and then someone else lasted 12 minutes, and then someone managed to last 100 minutes. Again, this is just totally fictitious data. I'm making it up as I go along. But I guess the thing that we can take away from this now is if I was to calculate the means, let's see what I get. 1 plus 3 plus 4 plus 7 plus 11. If I divide this by 5, I'm going to get 5.2. Now if I do it for the red, let's see what I get. 5 plus 8 plus 9 plus 12 plus 100. Divide this by 5, and I'm going to get 26.8. So, for those who had marijuana in this case, so those that are represented by the black numbers, they had a mean of 5.2, which actually isn't too bad when you look at the range of scores. But for those who had cocaine in this particular example, so my red numbers, a mean of 26.8 doesn't make sense. It's right up the upper end of the scale, and it's really because we have this one person who has this score of 100. So if I was to now instead calculate the median, if we start with those who had, say, marijuana, we can go cross off those, this is the median, so we have a median of 4, cross off this, and we have a median of 9. So now we have 4 and 9. So this is an alternative approach, right? This actually represents the data a little bit better. We can see that looking at those who had marijuana, their median and their mean are very, very close. But if we look at those who had cocaine instead, there's actually quite a difference in the scores. And our median actually represents the bulk of our data better than the mean does. Neither of them are even coming close to this score of 100, but the median appears to be less affected by it, and it represents more so the 5, the 8, the 9, and the 12. So This is just a conceptual way of trying to demonstrate the potential advantages of considering non-parametric analyses. Now, what's actually going on behind the scenes with this? It's not that non-parametric analyses are actually calculating medians, they're calculating ranks. So to get rid of the actual effect of values here, in a non-parametric analysis, a score of 1 is considered 1. In this case, our score of 3 would be 2 because it's the second lowest score. 3, 4, 5, 6, 7, 8, 9, 10. And then we can go, okay, so these here are all of the ranks for my for the people who had my marijuana, and for those who had weed, these are their ranks. And then we can do some fancy things with these. We could calculate the median of the ranks, the means, we can sum them up, we can do a whole host of different things. If I was to just sum the ranks for a moment, just as an example. For marijuana, it would be 1 plus 2 plus 3 plus 5 plus 8. I get a ranking of 19. And then for cocaine, 4, 6, 7, 9, and 10, I get a rank of 36. So by using these rankings, you are still technically working with medians, but you also get a better idea as to where the data is sitting. So this is another approach that non-parametric analyses will sometimes take. They will use these rankings rather than using an actual median.